So the criteria for success, if you want to be successful, we have to annotate the passage with one key detail for every 2 paragraphs, multiple choice questions answered using the HERE strategy, and it's all around the room for us to see. And then the short response answered using 2 complete sentences and correctly answering the questions using text evidence. I'm going to read this text for you. What is Earth? Why is Earth a magnet? Have you ever seen a globe like this one to the left? Magnets in the globe and its stand repel each other. That's something you should highlight, allowing the globe to hover in midair. So it's hovering. See, it's just balancing there. The globe is a good model for Earth. Like the real Earth, the globe pictured is a magnet. A magnet is an object that has a north and south magnetic poles and a magnetic field. Earth has a north pole right here and a south pole right here at the bottom. The magnetic globe is a modern device, but the idea that Earth is a magnet is far from new. It was first proposed in 1600 by a British physician named William Gilbert. He used a spherical magnet to represent Earth with a compass. He demonstrated that the spherical magnet causes a compass needle to behave the same way that Earth causes a compass needle to behave. This showed that a spherical magnet, meaning a magnet that looks like a ball, is a good model for Earth, and therefore that Earth is a magnet. Although the idea that Earth is a magnet is centuries old, the discovery of why Earth is a magnet is relatively new. In the early 1900s, scientists started using seismographic data to learn about Earth's inner structure. A seismograph detects and measures earthquake waves. Evidence from earthquakes showed that Earth has a solid inner core and a liquid outer core. See the figure below. Let's look at it. Solid inner core, liquid outer core, that's yellow. The outer core consists of molten metals, meaning that they're melted, and mainly iron and nickel. Scientists think that Earth's magnetic field is generated by the movement of charged particles through these molten metals in the outer core. The particles move as the Earth spins on its axis. Hence, Earth is surrounded by immense magnetic field called the magnetosphere. Get it? Our magnetosphere plays the role as a gatekeeper, repelling this unwanted energy that's harmful to Earth, trapping most of it a safe distance from Earth's surface in twin donut-shaped zones called the Van Allen belts. These zones are called the belts, like these lines that you may see. But Earth's magnetosphere isn't perfect. Solar wind variations can disturb it, leading to space weather. Geomagnetic storms that can penetrate our atmosphere, threaten spacecraft and astronauts, disrupt navigation systems, and wreak havoc on power grids. On the positive side, these storms also produce Earth's spectacular aurora, if you've heard of the aurora borealis, those lights in the air. The solar wind creates temporary cracks in the shield, allowing some energy to penetrate down to Earth's surface daily. Since these intrusions are brief, however, they don't cause significant issues. Nearly all of Earth's geomagnetic field originates in the fluid outer core, so from here. Like boiling water on the stove, convective forces, which move the heat from one place to another, usually through air or water, constantly churn the molten metals, which also swirl in whirlpools driven by Earth's rotation. As this roiling mass of metal moves around, it generates electric currents, hundreds of miles wide, and flowing at thousands of miles per hour. So basically, as the Earth is rotating, the electric currents continue to move, and that causes the magnets, the magnetic interaction, which we've already learned. At Earth's surface, the magnetic field forms 2 poles called a dipole, di meaning 2. The north and south magnetic poles have opposite positive and negative polarities, like a bar magnet. The invisible lines of the magnetic field in a closed continuous loop flowing into Earth at the north magnetic pole and out of the south magnetic pole. The solar wind compresses the field shape on Earth's sun facing side and stretches it into a long tail on the night-facing surface. All right, this is just extra information, but let's focus on our questions. So what allows the globe to hover in midair? Let's go to paragraph 1 for that. So I'm going to put P1/2 for the paragraph 1 and 2. Who first proposed the Earth is a magnet and when? Let's go back to right here. This is paragraph 2 and 3, because we're not going to give you the answer. And what did Gilbert use to demonstrate? Again, that's paragraph 2/3. What generates the magnetic field according to scientists? That is, let me see, 1, 2, 3, and 4. I'm going to say that's 3, paragraph 3. What is a magnetosphere? Also paragraph 3/4. Van belts, that is paragraph 3. Storms that can happen, that is paragraph 4. You can also pause this, guys. You have the power. What causes magnetic field? That's paragraph 4 and 5. How does the solar wind affect it? That's paragraph 5. And then the positive effects, that's also paragraph 5. And then this last one, you have it here. You're drawing your representation of a magnetic field around Earth. So how do you think it looks like based on the video that you watched and what you heard me say?